Hi there, I am Peter Strömberg, also known as Pess. I'm a huge Clojure fan, and I am also the creator of Calva, and one of its two maintainers, two very active maintainers, I should say. Yeah, and the other day I was demoing Clojure and trying to advocate Clojure and ClojureScript at FunkProg Sweden meetup. That was very fun and something I can really recommend. And something I also can recommend is doing what I dared to do there, live coding. Even if that particular demo, at the end, I entered a bug in the thing that I was coding, and the React Native sort of showed it in a spectacular way, and I stressed out, my brain shut down, I couldn't fix my silly little bug live. So then I watched the video myself, and so I see what my mistake was. So I was abandoning Clojure principles in a way, taking things in a bit too big chunks. Very small chunk still, but when you're coding just by yourself, and then you can take it in those big chunks. But the game changes when you do live coding. So then you need to step back even more to the principles and keep things really simple and small, the steps you take them in. So I was, that's why I'm want to do this and show you the end of that demo when it ends well. So let's go. Add application code here. And we have the app running here in the iOS simulator. And this app is very simple. It has a text here that you can find here in this reagent structure. And it's a React Native view, and then this text which shows tapped plus this counter. So this is 0 here, and the counter is lettered here. I don't know how you say it. We declare a local variable here called counter. That is a result of this subscription. If we look at this subscription in the REPL, it looks like this. It's 0 there, and that's what was displayed here. If I click this button, the state changes, and we have 5 here. And then if we evaluate this here, there you can see that's what you get from this subscription. And the button then dispatches this event. So this application is built with the ClojureScript, React Native, of course, reagent, and reframe. Reagent is a wraparound around React. Not all of React, some of it, and then we're using more Clojure for some parts of the application. But it lets you declaratively define your view like this. So these are just Clojure vectors. And we have, you see here also that we have this here. So I can show you if I comment that out or ignore it out, and then we save here. That's hidden in the view here. And if you can see, note here that the tapped still shows 5 here because it hot reloads it, keeping the state. And that's one of the major advantages with using this kind of tool, I would say. Because imagine that this was a much more complicated state, and you're going to fix how something looks or a bug or something like that. then you don't want to restart your app. So when you work with this, you likely very seldom restart the app. You just modify it as it is. You should probably see that demo at Frankfurt I'm talking about for this to make more sense to you. I'm telling you a bit of the background here, just so this should be able to stand for itself. But anyway, watch that video as well. I will have a link in the description. This application so when reframe is the thing that handles the state for us, and it's something modeled from Elm state model. That's common for Elm programmers, so that's the inspiration here. And you have like in this case you have a database. So this is the database, and it's in this case a very small Clojure map. It has a key counter which is 0, and the key counter tappable, which is true, and makes this true here. So if we initialize the database, that's what's happened here at init when the app starts, then everything is read from the database. So if we would change the state here, now we can't tap this. But then if I initiate the database, it will be enabled again. So this is how it's built. Like many Clojure applications start. They start with the data, and then you build bottom up. And then you interact with this database. You never modify the database directly. You read from it using subscriptions, and you modify it by dispatching events on it. So the subscriptions are defined here for this app. So here we see the get counter subscription, and it is a function taking the current DB as an argument, and then it's picking this counter key from the database. This is a function call, and keywords in Clojure are functions. When you use them as functions and then give them a map, they will look themselves up in this map. So we can show it. This is a reference to the real database here. So if we look at this, we see the current state of the database here, and we can click there and do this again, and see we have an updated database here. So if we on this database would call the function counter, then we pick up that 6 from it. That's what happened. And then we have the events. So this is, you've seen how this event can be used to inject the database. It just takes the database from here and returns it. So that's how these events work. They take the current database and they transform it in some way, returning a new database that then reframe uses to update that database. So this ink counter then, it takes the database here, and then we have 2 arguments here that we don't care about. That's so we just update the database on the key counter in it, and ink is a Clojure function that increases in its argument by 1. And we can modify the application without restarting it or anything by redefining this event. And now I'm calling decrement here instead. So now if I click this button, it should count down. So That's actually what happens here. So let's restore it to counting up. And now we can count up. So in that demo, what I then tried to do was to try to make this a Fibonacci counter instead. And that's very similar task to just counting up, right? So we start then in the database here and figure how it should be represented. The current state should be represented of Fibonacci. So we could have then current fibs, say, and that could be a vector of two numbers. And the Fibonacci sequence starts with 0 and 1. And so, like the natural numbers start with 0, Fibonacci sequence starts with 0 and 1. And then we can have this database. I redefine it now. So this is the current database we have. And then we can look at this database. Let's update the app database so that we can, a subscription, look at it. But we can first look at it like this. So we pick out current fibs from this. So look at this first now. It has the counter 0, current fibs 0 and 1. And if we pick out current fibs from it, we only get this vector with 0 and 1. And then we can create a subscription. It is very similar to this subscription. Maybe you can copy and paste it even. With that, we say, what can we call it? In the same way, you can get fib. Why not? And then we will, we can thread this. So we start with a database that we get in there, exactly the same way as we do here. And then we take the current fibs. Okay, the current fibs from it. So that's the same as here. So if we do it here again to remind ourselves, we have this vector, but we should just get one because we only show the current one here. So we should pick from this, we should pick the first one. So now we're calling the function first on that vector, and that will return the first one for us. So we should do the same here in our subscription first. And now we define this subscription, and then we can, let's hit this in the comment, and then we can subscribe to get fib. So if we do that, we get this reaction thing from because we need to dereference this, as this is a short way to reference it, and then you see we get the 0 here. So that's all good. Now we have a subscription. We could update our view here to, so instead of counter, have a fib here, and did we call it get fib? I think we did. And we can test this subscription here. Still, we have 0. We have nothing has changed in the database, and we can say fib here and fib here, and redefine this. We can actually save here and let shadow update the view, and it will show us the updates here. Good. That's we should be ready for the next step here then to define the event that will update this the current state and the next Fibonacci number and so forth. So that event looks very similar to this one. So we can do the same here and copy it. And we can say incfib, why not? And it takes also database, doesn't care about the other arguments. It updates the database, not the counter though. Updates the current fibs. And it shouldn't include, it should do something else. And here is where I went wrong in the last demo then. I started to type out the function here, and it was this very small function, simple. I thought I could do it without errors, but then I couldn't. So the thing is, what should we put here? Something, but we could instead have then try to define that function. Here, it's a bit, maybe if I do that, you see it easy. So here we can take the, we can do the same thing as we do. If we have a, first, then we have the database. We frame DB app DB. If we look at this, that's the first thing we start with here, and then on this we can call our new function. Then I can do a new function here, and since it's a lambda, right? So the red parents here, that's a function call, so it will call this. So, and if we just take this argument we have here in this function and return it, then this should just return what's in there, right? So we then should pick from this. We could pick the current fibs from X, and now that's returned, and we call this then we have the current fibs. But there are a quicker way of doing this. Actually, this is what we get in here. So we should actually pick that out first here. And then we get something in here, X. And if we now return X, that's what gets out. And then we can use, since it's a vector, we can use Clojure destructuring on vector. So now I say a match with the vector in here, and I have two numbers in here. One is fib1, say, and the other one is fib2. Now if we return, let's say a string with fib1 and that, and fib2, we get the concatenation of the first Fibonacci number and the other one. That's not what we want to do. We want to instead return a vector where the first number is fib2. And then the next number is the sum of fib1 and fib2 of that. So what we got in here is 0, 1, and what we give away then is 1, 1, because That's a new option. So now we're actually ready to insert this function here. I can take it and paste it here. And we can define this event handler. And now we need to test it by dispatching on it. So let's do that. Again, like that. And then we, the reason I can dispatch like this is that I have required these things here as convenience. And we dispatch ink lib. So if we do that, it returns nil. That's the return of the dispatch. But we should have, if things are working correctly now, also updated the database. So we do this again. And then we look at the subscription here. We get 1. And let's then dispatch this one more time. Yeah, we can actually see it here. So now it's 2. And we can dispatch it again. Next Fibonacci number is 3. Next Fibonacci number should be 5, right? Yeah, that's what we. And I think even since we have installed already everything here, and this still dispatches ink counters. If I do this now, yeah, we're not showing it, but anyway, that makes the database look different in this way. So the counter is now 7, and we have advanced the current fibs like that. So let's instead dispatch ink fib here. And save. So now, when I tap this, it should call ink fib, and this is now a Fibonacci counter. So that's what I wanted to demo on this. Now when I have more time, it's easier, and I can do it without many wrong steps. So I can really recommend live coding, but it's also very much nicer sometimes to just have some time and your brain is working better and it's not stressed. I hope this made sense, and again, watch that full demo, and then watch this again, and then things make more sense. Thank you for watching.